Hello, today we are going to start with variables, which is, well, it's an interesting topic. So we're going to start by defining what a variable is and kind of how it works. So a variable is just a number whose value we don't know. Typically, we can find a variable if we have an equation to work with, but we really can't do that if we don't have an equation. So let's go to the board. Or wait, oh, wait, I didn't click that thing over there to go to the board. I'm so sorry, guys. So now that we're at the board, so let's say that there is a number, right? And I'm going to put this number in a box, okay? So we got this nice little box here. So I got this box, and there is a number in that box, but I'm not going to tell you what that number is. So we can give it any name we want. Any particular name you want is perfectly fine. I'm gonna call this one. I'm gonna call this number David. All right. Sometimes you get bored of the regular ones, so like X and things like that, and people use that all the time. But I'm gonna call this one David. So David over here is in a box, and if I don't tell you anything else about that number, you can't really find out what it is. I have to relate it to a different number in some way. Otherwise, it's just like, oh, okay, there's a number in the box. Well, all right. That doesn't mean anything. So, I could write David plus 2 or David times 3. And that wouldn't really tell you what the value is. But let's say I did actually give you some information. Let's say I said David minus 3 is equal to 7. Well, in your mind, you're like, okay, so David is a number who, if you take 3 away from it, you get 7. Okay, so there's another number that if you take 3 away from it, you get 7. That number is 10. So we go, okay, so David has to be 10. That's pretty straightforward. And if we're able to do the equals, if we say that it is something, if it is a number of some kind or it's related to a number of some kind, then we can actually start trying to figure out what David is. But if I was being, particularly mean, I could not tell you any of that. And if I don't tell you any of that, well, then how are you supposed to figure out what that number is? That's not very nice. So let's say, for the sake of argument, that I want to make David really, really complicated, right? So, okay, so all right, David. All right, David in the box. By the way, if your name is David, I'm sorry if this is a weird one for you. I just picked a name at random. Okay, so let's say David minus 3. Can't figure out anything from that, right? That's because without an equal sign, this is not an equation. There are some kinds of equations that use something instead of an equal sign, but that's still just a replacement for an equal sign. So variables by themselves don't really do much. You need to put them in an equation or relate them to something before you can actually start working with them. So we are going to flip back to our presentation, and okay. So we know what a variable is. Now let's talk about substitution. So substitution is basically this idea that, you have variables, and then once you know what they are, you're just going to replace them with what they are. So let's go back to the drawing board real quick. And let's say we bring David back up. So David's in the box, right? Okay. And before, if I said, okay, so we got David. So we got David plus 10 equals 13. Okay. And over here, I tell you 2 times David plus 7 is what? So I'm asking you what this number is. Well, over here, we don't know what David is, so we can't exactly solve anything yet. But over here, David is just using numbers. Okay, so David plus 10 equals 13. So 3 plus 10 equals 13. Or, if you want to do proper algebra, you can subtract 10 from both sides. Okay, so David is 3. Now, we could try to, in our head, just go, okay, so 2 times David is 6 plus 7 is 13. But doing all those steps in the head is kind of annoying. We already know that David is 3, so we are just going to replace David with a 3. And just like that, we have substituted for a variable. So now we only got one variable. We got this question mark over here, and we don't know what that question mark is. So 2 times 3 is 6. 6 plus 7 is 15. So now we know that that question mark is 15. And if I gave us another problem that used a question mark, we would just plug in 15 wherever that question mark is. This is how substitution works. Once you know what a variable is, you just plug that variable in wherever you need to in order to solve problems. Pretty straightforward. To look at this in a slightly more formal setting, so, you know, something you might actually see in like a textbook or a college class or something like that. Let's say we have a function f of x is equal to, let's say, 3x minus x squared. Okay, so all of these x's have parentheses, so they are the same as this x. So if I were to write f of 7, that means that instead of writing an x in all of these parentheses, I'm going to write a 7 instead, because I have substituted that x value for a 7. So 3 times 7 is 21, 7 times 7 is 49, so 21 minus 49, so go ahead and subtract. So that'll be 8, 20, so negative 28, so negative 28. So if I have the function f of x and I plug a 7 in, f of 7 would be negative 28. By the way, f of x is typically just used to denote a y value of some kind. Functions are, well, they're a little outside of what we're going to do today, but just know that they exist, and usually you can treat them as y, but we write them as f of x so that you know what the x value is before you know what the y value is. So, you know, if you needed to plug in x and y, you could do that using those, but for right now, we're gonna gloss over that. All right, let's go back to our presentation. So we know what substitution is. We know how it works. Now we're going to talk about combining like terms. Okay, so basically, if we don't know what a number is, but we know how many of that number we have, we can just write how many we have. As opposed to writing, oh, you know, I have 1 there and 2 there and 3 there. I can just add together, you know, I have this many of that number. So to give that an example, so let's say I have 2, oh wait, that's not my brush. So 2x plus 5x equals 7y. Okay, so I don't know what x is, I don't know what y is, so I can't solve this equation. I can't get a specific value that I want. But this right here is a very long way of saying that I have 2 x's and then I have 5 x's. So 2 plus 5, that would be 7 x's. So 7x equals 7y. And hey, now we divide by 7 on both sides, we know that x is just equal to y. So that was actually a pretty useful thing we just did there. We made this whole long thing into just this right here. And this is very useful whenever you have to do a lot of algebra work. You just combine your terms that are what are called alike. So if my x's are alike, my y's and x's are unalike. So I add together all my x's by just using the number in front. And then if I had more y's, I would do those as well. But one example of terms that are not alike, so terms that are not alike, but a lot of people think they are, would be squares. So let's say we have 2x plus 3x squared minus 1x. And that equals 2y plus 3y squared. Okay. So our x terms are alike, but our x squared term is its own thing. So we actually cannot combine, these guys because they are 2 different values. It does not work that way. You can't combine x squared with x by addition. And to show you why, let's say we pick an x value. So let's say x is 2. That would mean x squared would be 4. Okay, so let's say we had 3x plus, let's just say it's just x squared. So that would mean that if we tried to combine them, and I'm going to highlight this in pink to let you know that this is wrong. Okay, so if we tried to combine them, we would get 4x to the third, or not to the third. Well, a lot of students like to add the powers, but you shouldn't. So let's say we just add them like that and say we get 4x squared. Okay, So let's see if 4x squared matches up. So if we plugged in a 2, 3 times 2 is 6. 6 plus 4 is 10, so it should be 10. Okay, so this is 4 times 4, which is 16. 16 is not 10. That's not right. So doesn't work that way. Can't do it that way. And now you might do what a couple of other students do, which is that thing I said where they add the powers when they're adding. Okay, so let's check that and see how that plays out. So if we try to do that, hold on, I gotta erase this too here. So let's say we tried to do that. You go, oh, I know the thing I gotta do. I just gotta add the powers because that's a 1 there. So 1 plus 2, that's 3. Duh, now it's fixed. No, not really. So x cubed would be, so 2 times 4, that's 8. So 4 times 8, that's 32. Guess what 32 is not? That's right, it's not 16. Those aren't the same. That's also wrong. So remember, your square terms and your non-squared terms are different numbers. They're different numbers. You cannot combine them through addition. Now, if you're multiplying them, then you can start combining them. But we're not doing that right now. We're not multiplying. We're adding. So when it comes to adding and subtracting, you gotta keep them separated. Otherwise, you're gonna run into problems. You're gonna run into problems that are not good. You don't want those. Trust me. I've seen this road many a times. You don't want that to happen. You don't want to do that stuff. So just keep your x terms and your x squared terms away from each other. They don't play nice unless you're multiplying. Okay. So actually combining what we can combine, that's not my brush. We can combine that with that. So 2x minus 1x, that would leave us with a single x plus, and then we still have the 3x squared because that is its own unique term. Then, of course, we've got the 2y. That doesn't change because, again, y and y square are 2 totally different terms, completely separate. So we get x plus 3x squared equals 2y plus y squared. And we're done here. And that is okay. There will be equations where you can't plug anything in, you can't substitute, you can't get one number equals. That is fine. You can be done without having to solve for a single number. That is okay. You don't always have to get x equals a specific thing in order to be done. So here, we're completely done. We've combined all of our like terms. There's nothing left to combine. So just be aware, squares and non-squares don't play nice. Same goes for cubes, fourths, all of that kind of stuff. Add and subtract your like terms. They are like if they are the same letter with the same power. Okay, so now we can close off all that, and let's go ahead and head back to our presentation. So back over here. So now we know how to combine our like terms. If you multiply them, we can multiply the stuff. So now let's talk about variables in equation. Okay, so now let's talk about how to solve. So, and I'm going to talk about how to solve. So you may have noticed that I already did a bit of solving in some previous lessons. It's one of those things that I struggle to get out of the habit of. So sometimes I just do it on instinct. But we're going to talk here about how to specifically go about solving for something. So basically, whenever you have a variable, you want to get that variable by itself. You can do that by reversing all of the operations on it. And let's look at a variable and talk about how we do that. So if you happen to have ever heard the word PEMDAS is something we use called order of operations. So it's parentheses, exponents, multiply, divide, add, and subtract. So multiply, divide, add, subtract, parentheses, and exponents. So like if you have, something to some power, you make sure to do that first. So if I had 3 plus 2 minus 7 times 5, let's say we had 12 divided by 3 plus 2 minus 7 times 5. This looks ridiculous. This looks awful. And they didn't put any parentheses on it. That's not very nice. So in order to do this, we would go down the list of things to do. So parentheses first. There are no parentheses here, so that part's already done. Then we go to exponents. There's no exponents here, so that part's already done. Then we do multiply and divide. So divide comes first. So left to right, you always do left to right. So left to right, so 12 divided by 3, that's 4. And we keep going, and we keep passing over all of that because none of that's multiply or divide. So 7 times 5, that'd be 35. And then in the middle, we have the +2 and the minus. Okay, so that's taken care of. So we did the multiply, divide bit. Now we're moving on to add and subtract. So now we're going to do that part. So left to right, always left to right. So 4 plus 2, that's 6. 6 minus 35. So 6 minus 35, that's going to be negative 29. So we've added and subtracted. And if there was more to do after this, we'd basically go back to the start and look for parentheses all over again. But we did everything here, so we don't have to worry about it. So normally when you are going forward, you use PEMDAS when you evaluate. So whenever you plug in numbers, PEMDAS is how you do it. However, we are trying to do the exact opposite of that. We do not want to evaluate. We want to figure out what a number is, darn it. So instead of that, so we're going to have 2x squared minus 5 equals, let's say, 28. No, 27. Okay, so now all we want to know is we want to know this x over here, right? Well, that's a problem because I can't use order of operations because this darn thing's in the middle of it. So instead of doing that, I'm going to do the opposite of order of operations. So instead of doing PEMDAS forward, I'm going to do PEMDAS backwards, which, if you read it the way I like to read it, it says SADMEP. I don't know what a MEP is, but just saying SADMEP makes me happy because it sounds like a silly word. So now, instead of doing all that stuff forward, we're going to do that stuff backwards. So instead of ending with addition and subtraction, we are going to start with addition and subtraction. So right now, all of this stuff has -5 on it, right? So we want to do the opposite. So the opposite of -5 is +5. So if we add 5 on this side, we're going to add 5 on that side. So that leaves us with 32. And the other side is still 2x squared. Okay, and I'm putting the parentheses around the x. You can put parentheses around the x, that's fine. So we have done all of the addition and subtraction. That's been taken care of. Excellent. So now let's do the division and multiplication. Okay, so we have 2 times x squared. So the opposite of multiply by 2 would be divide by 2. So that's exactly what we're going to do. So we get x squared equals 16. Awesome. So we've taken care of the, division multiplication. Now we got to get rid of exponents. So the opposite of an exponent is a root. So the opposite of x squared would be the square root of x. So we take a square root, and then of course you can go back and forth. So if we had like the third root, the third power, we would do like the third root. Fair? And of course you can go back and forth there. So right here, we need to get rid of that square. So we need to do the square root. Square root of 16 is 4. So x is 4. Yay! We have our answer. We didn't even have to get all the way down to the parentheses. Oh, and I forgot to put check marks on the other one. I'm sorry. I like doing the check marks. They make me feel like I'm completing a list, which can be helpful if you're going to solve and you forget the stuff. Just remember, SADMEP. It's PEMDAS backwards. So there we go. And we just solved for pretty complex in compared to some of the easier stuff you might have seen before. So there you go. There's an example. Work through it start to finish. By the way, if this was +5, so actually here, I'll highlight some stuff. So that was not at all what I wanted to do. So this, we added 5 because it was -5. So just in case you were wondering, if this had been +5, we would have subtracted 5. Also, up here, we divided by 2 because it was 2 times x squared, right? And the opposite of multiply by 2 is divide by 2. It cancels. So, had it been x squared divided by 2, the opposite of divide by 2 would have been multiply by 2. So we would have multiplied by 2. Those would have canceled. We would have multiplied the other side by 2. And if the x, for some reason, had been in a square root, so let's say square root of x equals something, then we would have squared both sides. So basically, whatever you do to one side, you do the other, but you want to do the opposite so that it gets x closer to being by itself. And of course, you want to do this after you've combined your like terms, so that way you only have the single x to solve for. So now go ahead and clear this off. Boo, boo, boo. All right, and then now we will go back to our regularly scheduled presentation. All right, so yep, there we go. And with that in mind, so whenever we meet for the sync hours, we are going to build ourselves an equation, and we're going to solve that equation. I'm sure you guys have seen bits and pieces of this before, maybe, or maybe you've just heard about it before. But I wanted to make sure we review it because moving forward, a lot of these skills are going to be very, very important. So if you need to brush up on anything, I'd recommend making sure you practice solving for an equation. Because being able to solve for one variable is very, very useful, especially when you have more than one variable you need to solve for. So anyway, that's enough for this one. Next time, we're going to go ahead and start... Oh, well, we'll talk about variables that can have multiple answers. I kind of showed you one today, but we didn't talk about it that much. Don't worry. We'll dive more into it next time. For now, just go ahead and practice this stuff. Make sure you do the independent practice, and I'll see you guys in the next video. Bye-bye.